So we're going to look at some of these final review problems. We definitely won't get through all of them, which is fine. I was going to focus more on the trig ones. There are solutions posted to all of these already, so anything you have questions about, you can certainly find solutions to them on Canvas. Thank you. Also, just so everyone's aware, so if you look down at the very bottom module, not the very bottom module, it should be close to the bottom. At the final exam review module, this is what we're working on today, the Pre16 final review problems. There's also a final from 2019. There's also a final from 2020 that I just posted and solutions to both of those. So if you're looking for practice materials, that's what I would encourage you to look at over the weekend. I definitely will not get your final posted today. So Monday is what I'm looking at for getting it posted. I haven't written it yet, but it'll get written. So
how long do we have to do it?
It'll be similar in length and time allowed as a midterm.
Oh, I mean like days wise.
Oh, it's due Friday.
Okay.
So yeah, so I'll get it posted Monday. It's due by Friday. You can do it whenever between then. So you should be able to find a window in that time to do it.
Okay, thank you.
You're welcome. Yeah, that's it. I suppose sooner, if you're debating whether to do it sooner or later, sooner is better for me because then I can get them graded sooner, but do it whenever works best for you. Yeah, all right, let's look at some of these problems. And again, I'm going to skip around, well, not skip around, but I'm going to hit the trig ones mostly. But if there's something you see on there, you're like, James, can we do that one? Just say, James, can we do that one? And we will do that one. Let's start with the first one. Obviously, there's not enough room to write answers on this paper, so you need other paper. Unless you can write really, really small. So suppose cosine of A is equal to -2/3. I'm going to leave it over here to do this. And we also know that sine of the angle A is greater than 0. Whoops, you might like to see what I'm writing. There we go. Find or evaluate the following. First, we want to find sine of A. Okay, well, we're going to draw a triangle. I personally don't like to put any signs on the side of that triangle. I'm going to draw my triangle like this. Right triangle, excuse me. Here's the angle A, and cosine being -2/3 is adjacent over hypotenuse. So I'm going to write my adjacent side as 2, my hypotenuse is 3. Yes, I'm ignoring the negative sign. I'm just going to fix it all in the end. This other side here, the opposite, I'm going to find using the Pythagorean theorem. So 2 squared plus the opposite squared equals 3 squared. So 4 plus the opposite squared equals 9. The opposite squared equals 5. The opposite side is going to be the square root of 5. And so I can now find sine of A. It's just opposite of hypotenuse, which is going to be the square root of 5/3. And I know it's positive because the problem told me. They told me sine was positive. I don't have to think any harder about it. On the other hand, fine. I'm going to add in the question. If I have to find tangent of A, it would be opposite over adjacent, which would be the square root of 5/2. But should it be positive or negative? Well, what quadrant do we know the angle A has to be in if sine is positive and cosine is negative? Yeah, right. If sine is positive, we're either, well, in fact, I like to cross out the ones we're not. So if sine is positive, we are not here. And if cosine is negative, we're not here. So we have to be here in quadrant 2. And in quadrant 2, tangent is negative. So that would be a negative √5/2. All right, let's look at the rest of the questions. They also ask us to find sine of 2A. Okay. So for that, we need the double angle formula. Sine of 2A is 2 times sine of A times cosine of A. That's going to be 2 times sine of A, which we just found to be √5/3. And cosine of A, which is -2/3. Simplifying this, we should probably write as one fraction. That's a 2/1 So my denominator is 1 times 3 times 3 is 9. And my numerator is 2 times root 5 times negative 2. So negative 4 root 5. There's my sine of 2a. It was given. So we started off with this information. Cosine of A is negative 2/3 and sine of A is positive. Next question. What's cosine of 2a? There's a number of ways you can find this. The way I always find it is by doing cosine squared of A minus sine squared of A. So I'm going to get cosine of A, which is negative 2/3 quantity squared, minus sine of A, which is root 5/3 quantity squared. And that's going to be positive 4/9. Sorry, root 5/3, not root 5/2. Positive 4/9 minus square root of 5 squared is 5. 3 squared is 9. And that's going to be negative 1/9. Are we going to have any proofs on the exam? I guess I'm not sure exactly what you mean by proof. I would say no generally, but you might be thinking a proof means something other than what I'm thinking it means. So I don't think so, but maybe if you want to be more specific with your question, I can give you a better answer. And now the third question here is to find, the last question is to find tangent of 2a. There is a formula for this. I don't know it. And the point of this question is not for us to know the formula. The point of this question is for us to know that tangent of an angle is sine of the angle divided by cosine of the angle. So we know what sine of 2a is. It's negative 1/9. Cosine of 2a, oh, sorry, I got that backwards. Sine of 2a was, oops, apologies. Sine of 2a was negative 4/5/9. Cosine of A was, sorry, cosine of 2a was negative 1/9. The 9s will cancel, or you could do the flip and multiply. Right? This is going to be negative 4/5/9 times 9/-1. The 9s do cancel. The negatives also cancel, and we get positive 4/5. Bonus question. Like, yeah, we love a bonus question. Bonus question. What quadrant is angle 2a in? Well, we know that sine of 2a is negative, and we know that cosine of 2a is negative. We also know what tangent is, but we don't even need to. If we know that sine of an angle is negative and cosine of an angle is negative, what quadrant do we have to be in? Quadrant 3. So the question is, are we going to have to prove anything like verifying the identity of trig functions using the Pythagorean identities, cosine identities, reciprocals, etc.? I mean, yeah, you will need to be able to use those identities possibly to simplify some trig expressions, or to maybe you could be asked to like verify that cosine squared plus sine squared theta equals 1 for a particular angle. Although I feel like I probably would, I feel like that's, I would be happy. I feel like you would be happy if I answered that question because it's not a particularly hard thing to verify. If you're plugging in an angle and squaring it and see what you get, it should be 1. But yes, you will. You need to know like the sine is, or the tangent is sine over cosine. That's definitely something you need to know. Let's look at, and again, as usual, if you have questions, stop me. I know Katie's not here to answer. She definitely asked a lot of questions, which is good. I'm sad that Katie's not here. Is she online? Is Katie online? No, I don't see her online. Oh well. But you guys can ask questions. I know Katie's not the only one that asks questions. She does often ask questions. So let's look at question 2. Find the exact value for cosine of 25 pi over 6. Okay, well, right off the bat, we know that the reference angle is pi over 6. We just have to figure out what quadrant. In fact, before we figure out the quadrant, we know that cosine of pi over 6 is root 3 over 2. And we need to find cosine of 25 pi over 6. Our answer is either going to be positive or negative root 3 over 2. We just have to figure out what quadrant the angle is in to know if it's positive or negative. So 25 pi over 6 is a little bigger than a revolution. Well, in fact, I think it's bigger than 2 revolutions. Right? When I see 25 pi over 6, I'm thinking 25 divided by 6 is like 4 with a little bit left over. So I am thinking I'm going to subtract 2 pi twice. 25 pi over 6 minus 2 pi is 25 pi over 6 minus 12 pi over 6, which is 13 pi over 6. And I can subtract 2 pi again. 13 pi over 6 minus 2 pi is 13 pi over 6 minus 12 pi over 6, which is exactly pi over 6. So 25 pi over 6 and pi over 6 are in the same quadrant, which is what quadrant? Well, yeah, first one, right? Pi over 6 is in quadrant 1. So our answer is that cosine of 25 pi over 6 is equal to the same thing as cosine of pi over 6, which we already know is positive root 3 over 2. All right. Here's the attendance form again, just in case any of you missed it. You make sure you fill out the attendance form when you have a moment. Let's look at the next one. Oh, as a quick aside, it sounds like some of you have finally gotten emails about the math placement test. Good, glad to hear it. All right, good. Awesome. So I would recommend, I feel like I would recommend taking the final before you take the math placement test. But I mean, do whatever is more comfortable for you. But I feel like doing this first makes more sense. So you're kind of like, I've done the stuff. I would also encourage you to look at the practice tests that are posted on an announcement I posted in Canvas a while ago. So there are resources for you. But again, I'm glad to hear you all finally got the emails that I said you would eventually get. I feel like this next question was meant to be something different. So it asks us to find cosine of 5 pi over 6. And it gives us a hint or a note that we don't really need. You can certainly note that 5 pi over 6 is 2 pi over 3 plus pi over 6. It feels like they're indicating to me that we need to use the angle sum formula, and we don't. We know what cosine of 5 pi over 6 is. In fact, the previous problem almost tells us what it is already. We know that cosine of pi over 6 is root 3 over 2. Cosine of 5 pi over 6 is in what quadrant? In quadrant 2. So cosine of 5 pi over 6 is going to be negative root 3 over 2. And that's all I would want anyone to do for that kind of problem. What I think the person writing this review meant to ask, I'm gonna add an extra problem here. Sorry, and if you already wrote down 4, I'm sorry, I got ahead of you. So I think they really want to do something like cosine of 11 pi over 12. So if you see an angle, and in fact, I'll be clear, right? If I give you an angle, I'll be like, use an angle sum formula to evaluate cosine of 11 pi over 12. So we need to write this as cosine of an angle plus another angle. And specifically, you want to pick angles that reduce in the fraction, meaning, so you can tell, so I should back up. You can totally change this to degrees if you wanted to. You can change 11 pi over 12 to 165 degrees, and then write 165 degrees as one option would be 120 degrees plus 45 degrees. That would totally work. But I feel like that's more work than my brain really wants to do. I know that if I can rewrite 11 pi over 12 as the sum of two fractions that both reduce to things with smaller denominators, that's going to work. So I'm going to pick, and I have really at least two options here. I'm going to pick 2 pi over 12 plus 9 pi over 12. those both totally reduce. Alternatively, you could pick cosine of 3 pi over 12 plus 8 pi over 12. Those also both reduce. What you couldn't pick would be 4 pi over 12 and 7 pi over 12, because 7 pi over 12 doesn't reduce. This is going to be cosine of pi over 4 plus 2 pi over 3. This is going to be cosine of pi over 6 plus 3 pi over 4. Either way is fine. I'm going to do it this way I started doing it first. So then we have to use the cosine angle sum formula, which is cosine of the first angle times cosine of the second angle. If it's a plus here for cosine, it's a minus here for the formula. So for the cosine formula, the sign changes. For the sine formula, the sign stays the same. And that's going to be sine of pi over 6 times sine of 3 pi over 4. Cosine of pi over 6, we've already done a couple of times. Can you also show us the degree method? Sure. So cosine of pi over 6 is going to be root 3 over 2. Cosine of 3 pi over 4. So I like, when I'm doing it this way, I always like to make my pi over 4 one the one that's in like a different quadrant, if there's one in a different quadrant. I think it's because I know that 3 pi over 4, both cosine and sine are already root 2 over 2. And I have to think about like which one's root 3 over 2, which one's 1/2. If I know both of these are root 2 over 2, I just need to figure out if any of them are negative. Cosine of 3 pi over 4 is definitely negative because it's in quadrant 2. Sine of 3 pi over 4 is definitely positive because it's in quadrant 2. And then sine of pi over 6, well, if cosine of pi over 6 is root 3 over 2, sine of pi over 6 must be 1/2. And then we simplify this. Square root of 3 times the square root of 2 is the square root of 6. So that's going to be negative square root of 6 over 4 minus 1 times square root of 2 is square root of 2 over 2 times 2 is 4. And then we typically write it as one fraction, negative root 6 minus root 2 all over 4. Well, let's do it using degrees as well, just to kind of, because it's totally valid to do using degrees. To me, it feels like a little more work, but that's okay.
I have a quick question.
Yeah.
I'm still confused because we're trying to find cosine of 11 pi over 12.
Yep.
Where is the sine part coming from?
So this is from, let me show you. Okay. Some of these pages are a little. So there are two angle sum / difference formulas. The formulas are that cosine of A plus B is equal to cosine of A times cosine of B minus sine of A times sine of B. That's a known formula. We didn't ever prove this formula. It is a little bit geometrically wonky to prove. Like we could prove it. It's not what you definitely don't want me to prove it for sure. We could at some point. Not in this class, obviously, because it's the last day of class. But if you ever want to see the proof of this, I will happily show it to you sometime in office hours next quarter. Speaking of which, after you guys take the final, I will post up my availability next quarter. So if you're looking to find me, I'm not teaching any classes next quarter. If you're looking to find me, like for math help, you are more than welcome to find me. I'm going to be very available. So I'll let you all know when and where I can be found. But don't worry about that right now, because worry about your finals this quarter. And then if it's cosine of A minus B, it's cosine A times cosine B plus sine A times sine B. There's also a sine formula. Sine of A plus B is equal to sine of A times cosine of B plus cosine of A times sine of B. And then if it's sine of A minus B, it's sine of A times cosine B minus cosine A times sine of B. So when I think about these formulas, I think about the fact that the cosine formula, whatever the sign between the two angles is, changes over here, right? Plus becomes minus, minus becomes plus. Whereas for the sine formula, the sign here stays the same. Plus, plus, minus, minus. And then each of the formulas have cosine and sine of each angle, right? I have a cosine A, a cosine B, a sine A, a sine B. I have a cosine A, a cosine B, a sine A, a sine B. I always think about all those pieces appearing. So let's do this one again. Let's first change our angle, 11 pi over 12, to degrees. 180 divided by 12 is not something I'm good at, but I can certainly reduce that fraction, right? So I really think it's not a good idea to multiply first. I don't want to make that number bigger. I'm really not going to multiply 11 times 180. Instead, let's cancel a 2. That's going to be 90, and then that'll be 6. Then we can cancel a factor of 3. That'll be 30, and that'll be 2. And then 30 divided by 2 is 15. Maybe I should stop there actually while I'm ahead. Let's write it as 11 times 30 divided by 2. Because I would rather multiply first now instead of trying to do 11 times 15. 11 times 15 seems hard, whereas 11 times 30 seems easy. It's 330. And then 330 divided by 2 also seems pretty straightforward. It's going to be 150 plus 15 is 165 degrees. So now we're going to write 165 degrees as one option would be 45 degrees plus 120 degrees. Another option would be 30 degrees plus 135 degrees. Right, this option has, obviously we know this one, and here the reference angle is 60. Here we know this one, and the reference angle here is 45 degrees. So you're always trying to make it into angles that add up to the thing we want. There are angles that we know how to find sine and cosine of because we know their reference angles. Let's do this first a way of doing it because that's different than what we did for the previous way. So if I want to do this cosine, right? I said cosine, yes. Cosine of 45 degrees plus 120 degrees. That's going to be cosine of 45 degrees times cosine of 120 degrees minus sine of 45 degrees times sine of 120 degrees. I know cosine of 45 degrees is positive root 2 over 2. I know sine of 45 degrees is positive root 2 over 2. And then 120, the reference angle is 60 degrees. And I know cosine of 60 degrees is 1/2. And cosine of 120 degrees is going to be negative 1/2 because that angle is in quadrant 2. And sine of 120 degrees is going to be positive root 3 over 2 because that angle is in quadrant 2. And then we get the same thing. Root 2 times negative 1 is negative root 2 over 2 times 2. Minus root 2 times root 3 is root 6 over 2 times 2. Something weird just happened over there. And then something weird happened on my screen. Like we're usually the little picture thing for Zoom doesn't show up on the side, but it started showing up for some reason. It might mean someone turned on their camera, although I don't see any with the picture, so who knows? Maybe someone unmuted themselves. It's all right. Oh, it disappeared. Okay. It's all right. And then this is negative root 2 minus root 6 all over 4, which is the same as our other way of doing it. It looks slightly different. And before we had negative root 6 minus root 2 all over 4, same thing. Other questions about this one? So it's okay to do it using degrees or radians. I will probably ask a question like this using radians, but if you want to change it to degrees, it's always an option. Okay. I'm going to skip questions 4 through 8 for now. I'm going to focus more on the trig stuff unless you guys want specifically me to do some of the other things. So let's look at number 9. Find all 6 trig values for theta equal to 7 pi over 6. Actually, we've seen a lot of pi over 6. I feel like I should have been pi over 3. It's all right. So sine of 7 pi over 6. First of all, I really should say my reference angle is pi over 6. And my quadrant is quadrant 3. And I know it's quadrant 3 because 7 pi over 6 is just a tiny bit bigger than pi. So sine of 7 pi over 6 is going to be negative. Cosine of 7 pi over 6 is also going to be negative. And tangent of 7 pi over 6 is going to be positive. Because we're in quadrant 3, where tangent is positive. If you like, you can draw the triangle. So I've obviously memorized it on this, right? I mean, I've taught this many, many times, right? I know that sine, well, most of the time I know that sine of pi over 6 is 1/2. Sometimes I get it screwed up in my head. So if you're not sure or you want to draw the triangle, totally a good idea. So here's my triangle. Here's my angle, pi over 6. Now you have to, if you're going to do it the triangle way, you have to make sure you get the sides right. Pi/6 is the smallest angle in this 30, 60, 90 triangle. Right? That's the 30-degree angle. The side opposite is the smallest side. The side opposite the right angle is the biggest side, or the hypotenuse is always the biggest side. And then the medium length side opposite the medium angle is the square root of 3. And that is the medium length side, right? 1 is less than the square root of 3, which is definitely less than 2. So make sure you get that triangle right if you're going to be using the triangle. And then sine of 7 pi/6 is going to be -1/2. Cosine of 7 pi/6 is going to be -√3/2. And tangent is going to be 1/√3. We should rationalize that as √3/3. And now the other values should be easy. I would always encourage you to write it this way: sine, cosine, tangent, specifically because sine over cosine is equal to tangent. So if you think about doing this over this, you get that, and you do, right? You get 1/√3 because the 2's cancel and good stuff. And then next to sine, I should write cosecant of 7 pi/6. And next to cosine, I should write secant of 7 pi/6. And of course, next to tangent, we should write cotangent. So signs, meaning SIGNS, right? The positive or negative, this doesn't change when you reciprocate. So cosecant is going to be negative, secant is going to be negative, cotangent is going to be positive. Cosecant is going to be -2. Secant is going to be -2/√3, which we should rationalize. It's -2 times √3 over √3 times √3. And then cotangent, I could say it's the flip of this, or I could say it's 3/√3, but it would be smarter of me to say it's the flip of 1/√3, so I don't have to do any more work. It's just √3/1, which I shouldn't even write. I should just say it's √3. So definitely try to make it easier, right? If you're taking the reciprocal of something, pick the something where the denominator is irrational, so that when you flip it over, the numerator is the thing that's irrational, if you have that written down. So when your angle is an angle that has a reference angle, this is the way I would encourage you to do it. But if your angle is a quadrantal angle, like 3 pi/2, right? And a quadrantal angle is just an angle that ends on one of the axes. So then I would draw a little unit circle. Like, okay, 3 pi/2 is that angle down there. And the point there is the point 0, -1. And I might, even if I was being especially smart, I might say, oh yeah, the first coordinate is the cosine value. The second coordinate is the sine value. If you're not sure, remember that it's alphabetical. X before Y, literally, cosine before sine, C before S. It's alphabetical. So now I'm going to do the same thing. I'm going to find cosine. Sorry, I'm going to start with sine. Apologies. It's too bad we do start with sine when we write this list this way because of reasons that, like, just over the years, this is the kind of people thought about doing it. But cosine is the one that comes first here, so be a little careful when you're doing it. I'm going to write sine of 3 pi/2 is equal to -1, and cosine of 3 pi/2 is equal to 0. And tangent of 3 pi/2, if I'm smart about it, I feel like, oh, tangent is sine over cosine, which is -1/0, which is undefined. Right? Division by 0, undefined. And then we get all the flips. Cosecant of 3 pi/2 is 1/-1, which is still -1. Secant of 3 pi/2 is 1/0, which is undefined. And cotangent of 3 pi/2 is 0/-1, which is 0. Whenever you find the 6 trig functions of a quadrantal angle, you always get 2 of them being 0, 2 of them being undefined, and 2 of them being either +1 or -1. Always happens. And specifically, it's either going to be sine and its reciprocal that are positive or negative 1, or cosine and its reciprocal that are positive or negative 1. And then you always get the other, like whichever one isn't 1, the other one will be 0, and then its reciprocal will be undefined. Yeah. So if one thing is 0, its reciprocal is undefined. If one thing is undefined, its reciprocal is 0. Okay. Let's look at the next one. Another hyper extended angle here. Sine of 22 pi over 3. Okay, this one I feel like is a little misleading, because you might make the mistake of saying, well, it's a little more than 21 pi over 3. Right? 21 pi over 3 is 7 pi. So 22 pi over 3 is 7 pi. I'm just going to write it this way. It's 21 pi over 3 plus pi over 3, which is 7 pi plus pi over 3. And it might feel like this is 7 full revolutions and then pi over 3, but it's not. Right? Because 7 pi isn't 7 full revolutions. It's 7 half revolutions. So I would kind of think of this as, oh, it's a 2 pi, it's a 4 pi, it's a 6 pi, it's a 7 pi. It's a 7 pi plus another pi over 3. So there's my angle. Probably not drawn very correctly, because pi over 3 should be a little more into the quadrant, but that's okay. Or you can do the thing where you subtract 2 pi a bunch of times. It's going to take a while, but you could say 22 pi over 3 minus 2 pi is 22 pi over 3 minus 6 pi over 3, which will be 14 pi over 3. Sorry, 16 pi over 3, apologies. Let's be better at the subtracting there. And then we do it again. Subtract another 6 pi over 3. You get 10 pi over 3. And then we do it one more time. And we end up with 4 pi over 3, which is the angle in quadrant 3 with a reference angle of pi over 3. So there's a couple of ways to get there. Either way, our reference angle is certainly pi over 3, and the quadrant is 4. Sorry, quadrants, what? Thank you, yes. I think I saw the 4 and the 4 pi over 3. I was like, oh, it's 4. No. Okay, so we know that sine should be negative. And we know that sine of pi over 3 is positive root 3 over 2. So sine of 22 pi over 3 should be negative root 3 over 2. Ooh, a graph. Let's give ourselves more room for a graph. Yeah. I'm going to not, so 13, I'm skipping 12 for just a second. This is 11, sorry. I'm not going to ask you to graph tangents. You should be able to graph tangents, but that's not what we're going to focus on. So just an FYI, I won't ask you to graph tangents. Let's look at 12. I want to graph one period of y equal to 2 times sine of 2x plus 4. And I'm going to try and show you how to do this writing down the least amount of stuff. So first things first, I want to find my period. So my period is going to be 2 pi divided by 2. And just to make sure everyone's clear, it's that 2 that I'm dividing by. All right, not that one there, that one there, which is going to be pi. And then I think we should find 1/4 of our period, which is 1/4 times pi, which is just pi over 4. Great, we have the period and we have 1/4 of the period, because each of our points that we care about, the 5 points, are each 1/4 of the period from the previous point. So We also want to find our starting point. Really, we don't need to do this here. The starting point is going to be 0, right? There's no horizontal shift left or right. But the way you would find the starting point in general is by setting the angle 2x equal to 0. And that's just going to give you x equal to 0. So your first important x point is 0. What's my next point going to be? Yeah, I'm going to take my previous point. I'm going to add on a quarter of a period. My third point is going to be the previous point plus another quarter of a period, which will give me 2 pi over 4, which you could reduce, but you don't need to. The fourth point is going to be the previous point, 2 pi over 4, plus another quarter of a period, which is 3 pi over 4. And finally, the fifth point is going to be the previous point plus another quarter of a period, which is 4 pi over 4, which is pi. And we can see that from the first point to the last point, we go from 0 to pi, which is 1 full period. And just to be super clear, right? Each of these points here, each of those are the previous points, right? 3 pi over 4 is the fourth point, and we're finding the fifth point. 2 pi over 4 is the third point, and we're finding the fourth point. And all these things here are the 1/4 of a period. And then I don't think you even need to write down what the amplitude and the vertical shift are. You certainly can, right? I suppose it's a good idea. The amplitude is 2, the vertical shift is 4. So now we're going to graph it. And we know we're going to shift up 4. So here's my new middle line. If you're going to draw a new middle line, I would ask you to draw it dashed. It does look kind of, some of you on your homework it was fine. Some of you drew it solid, no big deal. But it just looks like, it kind of looks like a different x-axis, and the x-axis should be right down there in this particular one. So if you're going to draw a new middle line, which I encourage, please draw it dashed. And then we know that at this new middle line of y equal to 4, we're going to be going 2 above it to a height of 6 and 2 below it to a height of 2. These are the highs and the lows that we care about. And then you don't have to scale this. In fact, I wouldn't scale this correctly because pi is about 3, right? I mean, ish. Kansas tried to legislate that pi was equal to 3. True story. Yeah, I know. Go look it up. It's kind of weird. They tried to like pi is equal to 3. Like, that's good. No, not really. Anyway, true. It's interesting, but not important right now. But if you notice, right, on my y-axis, that length is 3. And I don't want my x-axis to only go that far. It's just going to not look good. I'm going to be cramped trying to get my whole function in there. So just spread it out. Make a choice for your x-axis that makes it relatively easy to graph the thing. So I'm going to say that length is pi. I'm going to cut it in half, cut it in half again. And I don't really, I mean, you can label these. As long as you've written them somewhere, that's okay. Here it's pretty easy to label them because they're not going to interfere with where the graph is because the graph is totally above the x-axis. And then sine starts in the middle at my first x value of 0. And then my next x value, sine goes to the top. And then if you've gone to the top, you have to go back to the middle, right? If you're not in the middle, you're always going back to the middle. So you never want to go straight from the top to the bottom in trig functions or in life, right? Or straight from the bottom to the top, right? You have to go through the middle. So right, I mean, I know it sounds dumb, but like, right, literally for trig functions, for sine and cosine, you always have to go through the middle to get from the top to the bottom, to the bottom to the top. So middle, top, middle, then to the bottom. Or you can't go back to the top. You have to go where you weren't and then back to the middle. Should always end where you started. This one should continue this way, right? It shouldn't turn around here like that, right? It keeps going up just like it did over here, right? It should be a mirror of what's happening there. Could you post the parent graphs for the trig function? Sure, I can definitely do that. All right. There's our graph. Very excellent. Let's look at the next two questions. 14. Find all solutions where x is between 0 and 2 pi. Oh my goodness, that's terrible. Okay, sorry. So I will point out, this does say x is greater than or equal to 0 and x is less than 2 pi, because 0 and 2 pi are kind of like they're coterminal. They're not the same angle, but they give you the same trig function. So if you get 0 as an answer, you shouldn't also say 2 pi as an answer. If you do, I probably won't actually care, but I just want to point out, right? This is specifying that 0 and 2 pi, you should only say one of those things, since specifically 0 is the one we want to say. But I don't, well, it might come up. We'll see. I don't think it comes up. So let's look at the first one. We want to be finding the solutions to 1 minus cosine of x equal to cosine of x. So we should add cosine to both sides. So 1 equals cosine plus cosine is 2 times cosine of x. And then we're going to divide both sides by 2. So 1/2 equals cosine of x. So we're trying to find the angles in one rotation that make cosine equal to positive 1/2. So our angles should be in, well, in fact, let's just do it this way. What's our reference angle? Cosine of, is it pi over 6 or pi over 3? Pi over 3. Cosine of pi over 3 is definitely 1/2. So actually, that's even one of our actual answers, right? It's not just a reference angle. One of our answers in quadrant 1 is definitely pi over 3. What other quadrant is our angle in? As an answer in 2, 3, or 4? Quadrant 4, where cosine is also positive. So in quadrant 4, it's going to be not 2 pi over 3, that's in quadrant 2. 3 pi over 3 is pi, that's a quadrantal angle. 4 pi over 3 is in quadrant 3, and 5 pi over 3 is in quadrant 4. Or you could say, well, if I'm in quadrant 4, I need to be doing this sort of deal. I need to go all the way to 2 pi and then back pi over 3. So I can actually find it by saying, oh, it's going to be 2 pi minus pi over 3, which would be 6 pi over 3 minus pi over 3, which is 5 pi over 3. It's another way you could think about it. What rule is being used in the first step of A? I don't know if I'd say it's a rule so much, more that just, if we're trying to solve a trigonometric equation like this, you typically want to, if possible, isolate the trig function. So since I had a cosine and a cosine, I said, oh, I can put those together. So what I'm doing here is I'm actually adding cosine to both sides. So I'm saying the left side is going to be 1 minus cosine x plus cosine x. And the right side is going to be cosine x plus cosine x. And so then the minus cosine plus cosine, those cancel out. That's just 0. And cosine plus cosine is 2 times cosine. Let's look at the second part here. We want to solve sine of x equal to the negative square root of 2 over 2. So no frills here, right? We're not having to do any algebra to figure out what sine is equal to. They've already isolated sine for us. And we should recognize that our reference angle is which of our special angles? Yeah, pi over 4 for sure, right? Root 2 over 2, always pi over 4, whether it's cosine or sine, which is great. And then we know our angle should be in quadrants. Quadrants for sine is negative, so not the first or the second, but the third and the fourth. So in quadrant 3, our angle is going to be pi plus pi over 4, right? Because you're going pi and then pi over 4 more, which is going to be 4 pi over 4 plus pi over 4, which is 5 pi over 4. And then quadrant 4, you're going all the way around to 2 pi, and then you're going back pi over 4. So you're going to get 2 pi minus pi over 4. Again, this is not the only way to do it. This is just one way you might think about doing it. And that's 8 pi over 4 minus pi over 4, which is 7 pi over 4. Or you could say it's not pi over 4, that's in quadrant 1. It's not 3 pi over 4, that's in quadrant 2. It's got to be 5 pi over 4 and 7 pi over 4, because those are the next ones in the next quadrants. And it's not right. It's not 2 pi over 4, which is pi over 2. It's not 4 pi over 4, which is pi. It's not 6 pi over 4, which is 3 pi over 2. It's the ones that don't reduce. What time is it? Oh, it's almost. Well, that does get us through all the trig questions except for this last one here. So let's do this last one, which is a little bit ugly. So we want to simplify to a single trigonometric function, the cube root of tangent of x plus cotangent of x. Oops, that's kind of ugly looking, sorry. Over secant of x minus cosine of x. And if you all have paid attention to the James way of doing this, the first thing you're going to do is write things in terms of sines and cosines, right? That's like always, maybe not always, but almost always the first thing I'm ever going to do when I'm trying to simplify a thing like this. It just seems to make sense. So it's going to get even less nice looking, but that's okay. So tangent of x is sine of x over cosine x. And cotangent of x is cosine x over sine of x. Over secant is 1 over cosine x. I'm sorry, minus. And cosine is just cosine. So since we know we're going to want to get common denominators, we might just go ahead and take the step of multiplying cosine of x by cosine over cosine. So that I have cosine of x over 1. And then I'm going to multiply that by cosine of x over cosine of x. And I guess I have to do a similar thing in the numerator. In the numerator, I need to multiply. I'll just write another step. It's fine. So we're going to get the cube root of. In the numerator, I'm going to have sine x over cosine x times cosine x, or sorry, times sine x over sine x plus cosine x over sine x times cosine x over cosine x. All over. So in the denominator, I have a common denominator, right? I have 1 over cosine minus cosine squared over cosine. So I'm going to write that as 1 minus cosine squared x all over cosine. You could flip and multiply at this point. I would probably wait a little bit until I simplify things a tiny bit more. So in the numerator of this terrible expression, we have sine squared of x over cosine x times sine x plus cosine squared of x over cosine x times sine x, which I guess I should have put together. In the denominator, what do I have over cosine x? What can I replace 1 minus cosine squared with? Sine squared x. Right, we're definitely going to be using the trig identity sine squared x plus cosine squared x equals 1. Or in this case, if you isolate sine squared x equals 1 minus cosine squared x. So replacing the 1 minus cosine squared x with cosine squared x. I do want to really emphasize to everybody, I know we're out of time, we're almost on this problem. I really want to emphasize sine x does not equal 1 minus cosine x. You have to have the squares there. All right, so the numerator is going to be sine squared plus cosine squared. Oh, that's 1 over sine x times cosine x. So in the numerator, I have 1 over sine x times cosine x. In the denominator, I can't really simplify anymore. I have sine squared x over cosine x. So now I really should flip and multiply. So I'm going to say I have the cube root of 1 over sine x times cosine x times the reciprocal of this, which is cosine x over sine squared x. What can I cancel? What can I cancel? A sine or a cosine? A cosine, right? Because I have one on the top and one on the bottom. And in the denominator, I'm left with a sine times sine squared, which is sine cubed. Now that seems fortunate. I've got a cube root and a sine cubed. I'm kind of happy about that. So we have the cube root of 1 over sine cubed of x. The cube root of 1 is 1. The cube root of sine cubed is sine. And lastly, we shouldn't leave it like this. We should write it as cosine.